Hello everyone, I'm Rohit Sonar and today I will be explaining about MUX 4:1 MUX on Zilling software. So basically, as you could see, this is the diagram of 4:1 MUX where you could see that there are four inputs I1, I0, I1, I2, I3. There are two selection lines I0 and I1 and there is one output IY. Now this is the truth table of that specific mux, which is no other than 4:1 mux. This S1, S0 and Y. This S1 and S0 you would see are nothing but a selection lines, and this is the Y. This is the Boolean function. If we solve the truth table, we would get the Boolean function. This is Boolean function is nothing but a reduced format of the truth table. This is the circuit diagram. This is basically the given circuit diagram of the 4:1 mux, where you would see multiple AND gate, OR gates, NOT gates as well. Now this is the VHDL module of the 4:1 mux, where you would see this one. Okay, now as we could see the entity, where in the entity we basically represents and portray the port input and output ports, followed by architectural, and then the begin within the VHDL module. Similarly, within a VHDL test bench, we would see there is a where we basically write library AIEEE followed by entity, then architecture, in which we basically represent the port, okay, which are I and S are the input ports, whereas Y basically represent the output port, followed by inputs. This is the signal 1 and this is the signal S, whereas the signal S, STD logic vector 1, 3 down to 0 and 1 down to 0. Also you would see the outputs, which is basically represented by Y, and then followed by the port map, in which we basically represent the inputs and outputs. Now this is basically from where the actual simulation process starts, where we basically assign the number to every specific variable, and after assigning it we basically run that within a Zilling software, and this is the output which we basically obtain through through running onto that software. Now if we go here within the Zillings, we would see this one is actually 4:1 mux. This one is the 4:1 mux, where you would see there is AIEEE use. These are the standard format, followed by the entity, and then architecture and begin process. Okay, within the entity we basically, as assigned before, we basically represent inputs and outputs, followed by architectural behavior, which basically represent which gate we are basically been using, and here it basically represents the behavioral structure of that specific circuit, on which we are basically going to code the following respective program. Now after that we also have to write the program code for 4 mux, where it is followed by same library AIEEE, and these are the standard formats, followed by entity, architecture, where the name of the gate is been assigned and the port within component is also been assigned. As you would see, S and I are the input ports and Y is the output port, followed by inputs, and then output is basically been assigned, where in begin, here from where the actual coding starts, where we assign the codes for the respective variables S1, yes, and here you would see the different 0 0 1 1 1 0. These are the programs we are basically been given, and after which we basically get a specific output. This is the output which we get after the running the program. Thank you.